So recently I made a video about repairing the keyboard in this Amiga 500 with a PCB design, which I made in KiCad. And now I want to actually test the keyboard by using it for maybe a month or so. So, because I don't have anything to type on the Amiga, so rather than just typing random stuff and wasting my time really, I wanted to connect this Amiga to a Raspberry Pi through the RS232 port on the back of this Amiga and up to the Raspberry Pi UART port. To do that, I needed to design this circuit because the RS232 port has voltage levels, logic levels of positive and negative voltages, and the positive and negative voltages have to be above 3 volts and below 3 volts. Whereas the UART port, directly on the Raspberry Pi itself, it has to be 3.3 volts and 0 volts for the logic levels. But I'm using FTDI interface, so that can be 3.3 volts or it can be 5 volts and 0 volts. In this video I'll go through actually this in operation, and then at the end of the video I'll go through the circuit diagram and explain how the circuit works. So on the back of the Amiga there's a 25-pin RS232 port there, and I plug this board directly into that, and my FTDI cable connects onto the pins of this board. So I've got my Raspberry Pi here, and it's connected into the back of the Amiga RS232 port. And I've got a project which is an ESP32 project which I want to do development on. And that's unplugged from the Raspberry Pi at the minute because it sometimes grabs a USB port which I want to connect and create my session on. So my FTDI cable is plugged in, so hopefully I should be able to create a session on that. And I've got this NCOM software which is just terminal emulation software, and I'll start the terminal emulation software up. And I'll talk about how the connection status is, and why it's compared to modern day computers, it's very slow connection, but I guess for the time it was reasonable speed. I'm surprised how slow Amigas are. Certainly at the time it seemed like Amiga was really a quick system, but I guess compared to ZX Spectrum and stuff, it was a very quick computer. So I've got a login prompt here to my Raspberry Pi. So if I just log in, and look at the connection settings for the terminal. So the baud rate is 9600 baud rather than 19200, which was losing characters, so it was too fast. Even 9600 was losing characters, so I had to turn on X on X off, which is software handshaking for the RS232 port. But after that it works okay at 9600. So 9600 bits per second, so for bytes per second divide by 8, so you talk about 1k a second, which is really slow communications really. But I guess for terminal stuff it's not too bad, although actually doing development on this terminal from the Amiga at this speed is going to be a bit frustrating, I can imagine. But I just want to try out the keyboard and give it a good exercise and make sure it works fine. So if I CD to my desktop ESP32, I can set up the environments variables for ESP32 over this terminal session, and I'll plug in my project into a serial port. So I should be able to now upload. So there's my project running. I should now be able to flash a new build of the code onto that. I'll find the directory. So this is the project directory. So if I do idf.py, which is to build it, type flash to say flash a new build onto the project, and in a second you'll see the display go out when it's about to flash the new build on. So there it goes, and then it will reappear again once the new build's been flashed onto the ESP32. So that is booting up. So I can develop for my RS232 via the Raspberry Pi on my Amiga, and it's going to be quite painstakingly slow really to do the development over the next month or so, but it should prove out my keyboard. So I go over the way the circuit works. So the RS232 connection on the Amiga has 3 connections. One is common on pin 7. The next one is Amiga RX, so that's transmitting from the Raspberry Pi and receiving on the Amiga. And the final one is Amiga TX, which is transmitting on the Amiga and receiving on the Raspberry Pi. The easiest one to explain, so I'll go over first, is Amiga TX. So the signal can be anywhere between plus 3 volts to 15 volts and minus 3 volts to 15 volts. So the minus 3 volts to 15 volts is considered logic 1, and the plus 3 volts to 15 volts is considered the logic 0. All I do is bring that into a transistor, and the output on the transistor is pulled up to whatever the UART voltage is. So 3.3 volts if you're using the UART on the Raspberry Pi. And that output also goes through a 1K resistor to limit any current, just in case there's an error in the circuit or anything. And it goes into the Pi RX pin. And that just converts the RS232 logic voltages, which are plus or minus 3 to 15 volts, into a plus 3.3 volts to 0 volts signal, which the Raspberry Pi can understand and is safe for the Raspberry Pi to have on its input pin. So the more complicated of the pins is the Amiga RX, because I've got to convert from the Raspberry Pi on the TX pin a logic level which is going to be between 0 volts and 3.3 volts using the internal UART on the Raspberry Pi itself, into RS232 logic, which is going to be plus and minus voltages of 3 to 15 volts. So the first thing I do is take it for a transistor to switch safely from 3.3 volts and not have any risk of getting higher voltages on the Raspberry Pi pins itself. But I need to convert that into plus and minus voltages. So how can I do that? Well, I've got a circuit here, which if you saw my previous video is just a standard flip-flop circuit, but it's been converted to have these transistors here in place of the resistors which would normally go here. So it can drive and sync current. And this flip-flop circuit drives a thing called a charge pump. So it goes through these diodes here, and at each stage the voltage increases. So I go from the 3.3 volts of the Raspberry Pi, and it increases on each stage to something like it'll be plus about 12 volts. So I've got about plus 12 volts here, in comparison to the ground voltage which is coming along here. But that's just a positive voltage rather than a positive and negative voltage. So here I go for a standard potential divider, so it's just 2 resistors which divides the voltage in half. So the 12 volts then becomes plus or minus 6 volts, but it's plus or minus 6 volts relative to this point here. So I've got plus 6 volts coming out of there, minus 6 volts over this period here. But this, of course, for the Raspberry Pi is considered 0 volts. So you've got to look at this circuit as from 2 perspectives. So you can look at it from the perspective of the Raspberry Pi, or look at it from the perspective of the Amiga. And I'm going to switch looking at the perspectives now into looking at it from the perspective of the Amiga, because that's where we want the positive and negative voltages. So everything on the Amiga is going to be relative to what the Amiga thinks is the ground signal, which is here. So the Amiga thinks that this is 0 volts. So it has relative plus 6 volts and minus 6 volts here, which we're going to use as the signal. And like I said before, this is where the transmit signal from the Raspberry Pi comes out. So this is going to be switching this transistor, and it's going to be switching the transistor from this point here, which from the Amiga point of view is the minus 6 volts over here. So that's one side handled. So it's going to swing from minus 6 volts according to what the Amiga sees, to the positive voltage here, which is pulled up to this point here, which is the plus 6 volts that the Amiga is going to see. So as far as the Amiga is concerned, the signal that's coming out of here relative to its ground is going to be plus and minus 6 volts. But from the point of view of the Raspberry Pi, the signal that's coming out of the transmit is going to be 0 volts to 3.3 volts. So that's how you convert, from the point of view of the Amiga, you convert 3.3 volts from the Raspberry Pi into plus and minus 6 volts signal on the Amiga's receive pin. And that's what makes the RS232 communications possible between the Raspberry Pi and the Amiga. So I'll just show the voltages for the logic levels on the receiving Amiga side for the RS232. So I've got my voltmeter on the what would be receiving for the RS232 on the Amiga connector, and currently it's positive 3.5 volts. I've got about 3 volts coming in through the actual power connector here. So the output of about 3.5 volts is within the RS232 specification. So that would be for the negative. But if I go swing to positive side, positive logic, it swings to minus 3.5 volts. So the logic swings from positive 3.5 volts to minus 3.5 volts, which gives me the logic levels I require for the terminal communication.